Am I supposed to be? Hey, you can sit in the JavaScript seat. So you get the Java.
Guys, it's about time to start. Please take seats.
No.
You out. So we're about to start Routing Working Group meeting here in Montreal. Welcome. And we'll start with Working Group update. Unfortunately, Chris has to stay home, so it's going to be just me and Injing. So not well, always updated. You'll see it whole week. Please read it and agree with what you read. IPR disclosures, we call IPR disclosure twice. Once when we update the document or adopt it in working group, another time when we last call it. So remember, without IPR disclosure published, document will not progress. We are still looking for JavaScript. Anyone? Thank you. So we've got busy agenda for both days. This agenda for today. So agenda for tomorrow is a bit different than usual. We've got 2 large slots dedicated to particular topics. One of them is the control user plane separation. Another one is SD1. So we'll be focusing on these particular topics with some other presentation in between. We've got 3 new RFCs. Wow. So well done, working group. We've got number of documents submitted to ISG, and young models are waiting for single draft to progress, and Ignas is here. Hopefully he is going to do it soon. And the rest is just normal processing. I see the shepherd of this document, someone here, right? Graph? Graph? It would be really great to finally get the shepherd. Thank you. So after shepherd review, it's passed. Working group last calls will proceed to ISG. So, number of existing working group documents being worked on. Upcoming adoption call, the Rtgwg model. It's being reviewed by young doctors, and we are expecting review from routing directorate. Same goes for draft template. Draft Bashandi, we will adopt as working group document, which doesn't necessarily mean that we are happy as working group chairs with the way editor have responded to our comments, so we'll do something about it. But we decided to adopt this document. It's important. There are 7 implementations, so after IETF. Greg?
Okay. So how does it work now? Good. Okay, let's go next slide, please. What the problem is in the document? The document is informational, and I try to do analysis of existing encapsulations and how OEM is identified. Active OEM does fault management and performance monitoring for protocols, and we have hybrid OEM that being identified in RFC 7795 as something in between that uses. Is it echo there? Okay, better. One of the example of hybrid OEM are alternate marking method in situ OEM and hybrid two-step. There's drafts RFC on that, so you can easily find being listed in a presented draft. For overlay network protocols, we have 2 groups to look at. One of them allow metadata in encapsulation in a header. Another is that doesn't allow them. And to that, I refer as a fixed size header. Might be not the best term because they're first mentioned, above mentioned, the Geneve, SFC, MSH, and GUI, they can have fixed size with their base header, but the difference is whether you have metadata as an option or you don't. Next slide, please. So in the first, if we look at headers with the metadata. So here we can see that how definitions are done in Geneve and in GUI. In Geneve, they have explicit O-bit to indicate the OEM packet. And in GUI, it has a C-bit or command bit, which defines their interpretation of command type field. So if the C-bit is set, then the second field interpreted as a command, and that gives separate namespace for identification, and that includes OEM. It's not clear what was the goal of designers of this encapsulation, because OEM is not necessarily something that is always done in a control plane. And one of the examples could be BFD. So let's go to the next slide. SFC and SH has quite extensive number of documents that related to OEM definition. In RFC 8300, it just clearly says that all bill indicates the OEM packet. OEM framework talks about the presence of OEM in a header and possibly being following their NSH encapsulation. The new draft in IOM NSH states that all bit must not be set by the regular traffic, which is the payload traffic, and it must be set for IOM data. So again, we have some interesting situation where their active OEM is not well defined. Can we go next slide, please? RFC 8296 defines for the beer, and that is very simple. Yes, beer is a fixed size encapsulation, stands for bit index explicit replication. So OEM is one of the payload types, and the IANA has a registry for this for beer. VXLAN GP recently updated and introduced OEM flag bit, and that in addition to existing next protocol field. Okay, next slide, please. So for the protocols that do have OEM bit and next protocol field, there seems to be ambiguity in how OEM payload for active OEM is defined. So what is OEM packet? Is it OEM commands and information present in the metadata, or OEM commands information that immediately follow the header? RFC 8393 that describes the use of NSH with the next protocol field as none, so no payload, suggests that all-bit combination of all-bit set and next protocol none can be used as active OEM. That's very much true, but the problem is that TOV for metadata type 2 is limited to 512 octets, and Geneve has even smaller limit for TOV length in metadata to 128 octets. So which limits ability to use this approach to generate synthetic traffic of arbitrary length. So again, the documents are not really clear about how to identify OEM command information that follows their encapsulation header. Next slide, please. The recommendation I would suggest propose in this draft are the following. If the encapsulation allows metadata, then it may use OBIT to indicate the presence of OEM information in metadata. OEM commands and information that follows directly the encapsulation should be indicated by next protocol field. Next slide. We have another issue with MPLS data plane encapsulation. In current implementations and current approach, we use Martian address with an additional IP-DP encapsulation to identify the OEM protocol. Alternative is to use GAL label and GASH header, so generic associated channel header, to identify the type of the payload. That creates some issue that with the using GAL GASH, their source identifier needs to be explicitly stated. So that's something to point to overlay networks over MPLS that don't have the source information, that for OEM, there needs to be a source identifier included. Next slide, please. On-path OEM identification. As mentioned, the on-path can be different character. It's either to trigger performance measurement or to do collection and transport of measurement results and telemetry information. Example of the first protocol is alternate marking method, discussed in RFC 8321. In situ OEM combines both. It can be used as a measurement trigger and at the same time has the provisions to do collection and transport of information. Hybrid two-step is a proposal to do collection and transport of information of arbitrary volume. Next. So the next steps would be to do non-IP encapsulation for AM packet, update document on information on the GUI because current version doesn't correctly reflect the state of art of GUI. Appreciate your comments and suggestions, and would like to discuss with you where to take it further.
Any questions to Brooke? So Greg, you'll be presenting this draft in 2 or 3 more working groups during this IETF. What are your intentions? Where do you want this draft to leave, and how do you see the progress?
Right. So I think that there is some concern. Well, I have a concern with the current state of identification for OEM, and I think that the positive outcome of this document would be that there are certain updates to documents in SFC, NVO3 group, and int area.
So if you could, after you've presented everyone else, to kind of gather comments and come up with updated drafts would be great.
Okay.
Thank you.
Thank you.
Fred?
Okay, so this draft is titled A Simple BGP-Based Mobile Routing System for the Aeronautical Telecommunications Network. So just some background. The International Civil Aviation Organization, which by the way, the headquarters is within walking distance of this building, they're building an IP-based networking system for worldwide air traffic management. They're developing what they call the Aeronautical Telecommunications Network with Internet Protocol Services, or ATN IPS. And again, as under development in ICAO Communications Panel Working Group I, it's going to be an IPv6 based network with mobility capabilities, quality of service capabilities, and multi-linking capabilities. And it accommodates aircraft with multiple data links. Some of the data links used by aircraft are SATCOM links, LDAX is a new cellular link that's being developed, VHF radio, and there are many others like Aeromax and Inmarsat and Iridium. So we've developed a draft that we call a simple BGP-based mobile routing system for the aeronautical telecommunications network. It's a BGP overlay network that's separate from and removed from the global public internet BGP routing system. So there's no routing exchanges between this overlay network and the public BGP routing system. It's based on a hub and spokes arrangement where we have regionally distributed stub autonomous system border routers and centrally located core autonomous system border routers. The stub autonomous system border routers advertise and withdraw airplane mobile network prefixes. So each airplane gets its own IPv6 prefix that it carries with it wherever it goes. It might be a /56 or a /64. However, ICAO decides to portion those prefixes out, but that plane is going to own that prefix. The core autonomous system border routers are in a hub autonomous system, and they forward packets between the stub autonomous system border routers. And then proxies connect data link subnetworks to the overlay. Clients are aircraft that may connect to multiple subnetworks if they have multiple data links. And route optimization can be used to remove the autonomous system border routers from the path. So in terms of a diagram, this is what it diagrammatically looks like. We have the aircraft out on subnetworks, and you notice that some aircraft have multiple connections to subnetworks because they have multiple data links. The internetwork connects the subnetworks to the autonomous systems. There's native IPv6 within the subnetwork, and there's tunnels across the IPv6 internetwork. So in this diagram, the routers that appear in green and purple, the green are the stub autonomous system border routers, and the purple are the core autonomous system border routers. And between them, they run a BGP overlay over the internetwork. So in terms of BGP details, each stub autonomous system border router is a stub autonomous system unto itself, while all core autonomous system border routers are members of the same core autonomous system. The stub autonomous system border routers advertise their associated airplane mobile network prefixes to this core autonomous system border routers using BGP, and the core autonomous system border routers originate default but do not advertise any mobile network prefixes to the stub autonomous system border routers. So the spokes only know about their associated aircraft, while the core knows about all aircraft to spoke associations. So this core autonomous system border routers discover all the mobile network prefixes in the system using iBGP, and they can connect the overlay to the global public internet, in which case they would advertise a short and unchanging prefix that aggregates all the MNPs. For example, they would advertise a /32 instead of the dynamically changing more specific MNPs. So more in terms of what the hub and spokes looks like. This is the figure that comes from the draft. It's a little bit detailed. I won't get into it here, but again, the core autonomous system border routers are in a core autonomous system using iBGP. The stub autonomous system border routers connect stub autonomous systems, and they advertise client mobile network prefixes to the core autonomous system border routers. And again, the core autonomous system border routers originate default, but do not advertise any mobile network prefixes to the stubs. And again, it's a hub and spokes overlay network manifested by tunneling. Changes since the last version, we've had quite a few comments on the draft. We removed the discussion of route optimization and multi-link mobility. These items are covered under other drafts. We've focused the document on the BGP topology and routing interactions, and we've emphasized that inter-autonomous system mobility events and quality service updates are not propagated into the BGP routing system. Here's a pointer to the draft. It was presented at ICAO Working Group I Mobility Subgroup, and it's under active consideration there as a mobility solution candidate. It's been presented in previous routing working group meetings and also at the LISP working group in IETF 101 and 100. And now we're offering it as a routing working group item. So this is a question as to whether we can have this draft as a working group item. Any questions or comments?
Thank you. So I would like to thank you and co-authors on working closely with chairs to bring it to the state that we feel it's really ready to be adopted in the routing working group. Don't for a question. And we've requested review, and I believe Stuart, you've been asked to provide early review to it. And after IETF, we'll also start working group adoption for the document. Thank you again.
Actually, sorry, I do have a question.
Fred?
Sorry, I was tardy. John Scudder. Just apropos the working group adoption, what status do you want to have for the document? Informational, I assume? Or?
I believe it's informational we're looking for, yes.
Right, thank you.
Okay, thanks.
It's an architectural document that's informational. Yes. Rob?
Right, so Rob Wilton, Cisco. So I'm presenting the Yang data model for ARP. It's been presented in the routing working group at least once before, maybe twice, I can't remember. I'm one of the authors on here. I'm not the editor here, they're not here today, so I'm presenting on their behalf. I'll try and keep this fairly short. So this is really quite simple. Our plea is that we're really requesting routing working group adoption of this ARP Yang model. Hopefully it will then flow through the working group in a fairly expedient process. But at the moment, just to settle for working group adoption is what we're after. Why is this needed? So obviously some of the ARP Yang functionality is covered in IETF IP. So that covers all the basic stuff with dynamic and static ARP entries. And the purpose of this draft is to cover the extra bits of ARP that lots of vendors implement, but aren't covered by those, it's the standard Yang model there. So things like ARP statistics, global ARP entries, and proxy ARP. So it's not a particularly exciting draft. It's not a new protocol. It's not great. It's not going to save the world. But having a standardized model here does make life easier for operators. So if everyone can talk in the same way, then it just makes life easier for everyone. And we're not looking for perfection here. There's been various Yang models that have taken years and years to go through IETF. We're hoping that this is a fairly basic Yang model that should be able to go through reasonably quickly. It follows sort of fairly reasonable design patterns, meaning that functionality that not everyone's like to implement is made optional, put it under if keyword statements, that sort of thing. And we're on to the third revision, so we think we're at the stage we're ready for adoption. So really, his question is, can you help? Can you either show support that you think that this is a good thing that IETF is working on, and are you willing to do that? Will you also, having a few more people to review the document and provide feedback and input would be great. But as I said, I'm hoping that if it gets adopted, we can move reasonably quickly with it. And that's it. I mean, I have got slides showing the current model, and I have got slides showing what's changed, but I don't think that's really particularly relevant. I think what's important here is actually getting support from the working group.
Thank you. So from our perspective, draft is ready for adoption. We've requested Young Doctors review and early review from Routing Directorate. After we are done, I think we could try to fast track it to next steps. Yeah. Thank you.
AC Lindem, Cisco. Say, this is a procedural matter. I noticed that you put these, a number of these drafts in call for adoption state in the tracker. You were going to send out an email as well, right?
Oh yeah, absolutely.
Okay, good.
So they're in process, and before they've been reviewed by Young Doctors and the rest, they're to be adopted. They're not being adopted. No, not yet. Engine.
Hello, everyone. My name is Yingzhen. Here is an update of the routing policy Yang model. So what have changed since last IETF? Here is the list of things that we've done. So we make it more look like IETF model, because this one was originally one of the open config models. So we are now exporting the Yang types, the routing Yang types that's defined. That's already an RFC. And we also reduce more grouping. And we added, so I will go to the detail for the action we added. And another thing is we updated the BCP example that's used in this model. And one thing we see is BCP also has some policy defined in the BCP based model. So we'd like to collaborate with BCP model authors to see whether you want to keep them in BCP model or you want to put them into this policy model. So let's talk about it offline. So this one, just to refresh everybody's memory, this is the structure of the data model. So we basically have a list of models and then each list of policies. So each has some statement. You met certain condition and then your policy has some actions to it. So the bottom two actions that's highlighted are the new one we added. So once your policy matches certain conditions, what you can do with the actions you can perform. It used to have only you either accept a route or reject the route. So we added, you can also set a metric and also set or maybe set preference, route preference. So if you have some other actions you want to add route policies, please let us know. So this model, we'd like to progress it quick. So we want to collect more comments and we'll start the Yang Doctor review soon.
Jeff Haas, if you could go back one slide. I apologize, I do owe you feedback. It's on my queue and it's been there for a little while. So you give examples of set metric and set preference being, in this case, 16 and 8 bits wide respectively. A lot of implementations will vary on internally what they use such things for. Is there a reason why you didn't go for allowing for like a UNT32 and then allowing for implementations to put modifications on how wide they're going to allow those to be?
So for example, for the preference, I think right now most implementations you have defined between 0 to 255. That's why we picked UNT 8. So if you have different opinions or you have some special requirement, we can talk about it.
Yeah, our implementation goes much wider than that.
Oh, okay. So
again, my point being, rather than, and this is general advice for the module as whole, go for a larger number space, but allow for implementations to provide variations that they can discover in Yang, through extensions that say, I'm going to define this as event 32. This implementation may type def this, 0 to 255.
So you are saying we maybe change the preference to 16-bit?
Or 3232 and then allow it to be restricted. I will send details offline, but
yeah, I guess that will be based on some implementations. They have to do the verification. So because once you do this allow you to define a bigger number, then it's allowed, right?
Yeah, channeling a colleague of mine, constants are always wrong, so it's better to be a little more progressive.
Yeah.
AC Lindum, I believe metrics, most people have bigger metrics than that in 16.
Okay.
But for the preference, I agree with you there. I didn't know there were more than one. But the way to do that, I guess, would be to have a deviation and do a refine statement that refines the range on it. Yeah.
Or we may do a unit, so you pick the one that's right for you. Yeah.
AC Systems, Cisco Systems. I think that would be preferable to the implementations that have the smaller range.
Okay. Thank you.
Thanks. So policies are fundamental for any routing protocol, and we are in routing working group. So please do review this draft. We would like it to progress. There are a number of things in protocol that are pending because redistribution, some other things. And Jeff, thanks for your comments. Please review whether it works for your implementation, and we will try to find a common way of treating deviations and working with it. But please do review it, it's important. Asim?
Yeah, Sim from Cisco. I'm going to talk about QSing model. So going to talk about these topics. So in the last IETF, we got set of comments, and based on those comments, we had weekly meeting to resolve those. And based on those meetings, we were able to publish the new model. Essentially, two set of comments were given in the last IETF. One was related to the units for rate and burst. Unit for rate was defined, rate was defined as a value rather than value and unit. The unit was implicit. Similarly, for the burst, the value was defined, but the unit was implicit. What we have done in the current model is explicitly define value and unit. So the unit for rate will be bits per second as well as percentage. The unit for burst will be bytes and millisecond. Another set of comments which we got from the last IETF was regarding queues and scheduler. So we had defined queues and schedulers as a grouping, but it was not stitched to the draft. It was not stitched to the rest of the model. So we were thinking that, you know, all the vendors based on their implementation will be able to augment the way they stitch their model. So there was no common mechanism to, you know, stitch queues and schedulers to the rest of the model. Based on the discussion we had and the comment we got in the last IETF, we have worked hard to define queues and scheduler policy. The way it works is that we have defined two different modules, queues and scheduler policies. Queues policy is nothing but set of queues with classification based on traffic group. Now traffic group is nothing but metadata information which is carried from input to the egress of the network device. And the queue policy is nothing but the classification of the traffic group only. Now some vendor do support classification not only on traffic group, but lot of other filter parameters, for example, 5 tuples. So for that, what we have done is that we have defined queues which are stitched to the diffser policy as well. Similarly, we have defined scheduler policy. Now scheduler policy is nothing but set of scheduler parameters with an associated queue policy. Now scheduler policies attached are applied to a particular interface. But again, you know, there are vendors which support scheduler based on set of parameters. So it may not be just, you know, the traffic which is coming through the interface, and scheduling policies applied on all of that. So it could be based on certain filter criteria. And based on that, we have allowed scheduler parameters to be configured as part of the diffser policy as well. Again, okay, so that is pretty much it. So To summarize, we have defined a QS framework, which is for QS policy, classification, action, target, and as well as queues and schedulers. This particular model is pretty adaptable, it is augmentable, and it is pretty extensible. So as a next step, we got some comment in the last IETF from this community. I will suggest that, if you have any further comments, please provide us, and we should be able to take care of it. Also, some of the vendors are trying to prototype this model. Some of the vendors are actually waiting this model to be adopted by a working group. And once it is adopted by a working group, then they will be ready to implement that. In fact, in the last IETF, I made a call for adoption, and because we got certain comments, so we were taking care of the comments. But because we are taking care of the comments, if there is no further comments, I would say we should adopt this one.
So modeling of QS is probably one of the most complicated topics. There's many QS implementations as there are routers. Do you feel, guys, we are converging? Do you feel the draft in the current state addresses your implementations, or at least gives you ability to augment what has been defined so far? Are we converging? Anyway, you could comment on the list. I would really like to see your EI if you feel you could take this and adopt with some minimal changes to it.
Yeah, essentially, this draft was earlier part of the NetMode working group. We had got certain set of comments from them. We had incorporated those. Then it was moved to routing working group. We have got certain set of comments from routing working group. Now we have incorporated those. So I would say if there's no further comments or something, we should actually.
Please do comment.
Okay. Thank you. So in the operational Yang model, I'm going to talk about, the operational statistics and all that for QS.
Does it work? I'll do it for you then.
Okay, next slide. Okay, so in the earlier version of the model, we had a set of QS statistics as classifier statistics, queue statistics, meter statistics. All these set of statistics were directly augmented to the interface. What does that cause is that if somebody is looking for the whole QS statistics for one interface, they have to execute 3 different commands. So we found that this is not good, and we can have a better framework. And so we created a better structure with and that caused that, the whole statistics can be retrieved per interface basis, and also it is better augmentable. So for example, if somebody has to augment the whole QS interface stat structure, it can be augmented to a particular container rather than augmenting to the interface, and then the interface augmentation will be related to the interface rather than the QS. So based on those discussions, we have come up with a new version of the draft. Next slide. So essentially what we have done is that we have created a separate container which will have per direction list entry. Per direction list entry will have a classifier stats, meter stats, queue stats, and aggregated name stats. So if somebody wants now QS stats per interface can be retrieved. QS stats per direction per interface, it can be retrieved. And then QS stats per classifier per direction per interface, or per queues per direction per interface. Similarly for meter and name stats, it can be retrieved separately. So that way it is pretty much flexible. Also, I would again try to elaborate that aggregated name sets is nothing but the classifier sets which are aggregated based on a customer requirement. So for example, if a customer want aggregated set of stats, classified sets. So then it can create a name across it, and it will get an aggregated sets. So that way, in certain platform where there are lack of hardware resources, as a lack of hardware counter resources, then it can be presented in an aggregated manner, and that way hardware resources also can be saved. Yeah, next. As a next step, yeah, I would again, request this community to provide any further comments on the statistics part. And also, there is a QS telemetry requirements draft, which elaborate the requirements from the telemetry perspective for QS. So we are looking closely into that draft and see what extra changes which we have to bring into this model to suffice some of the requirements listed in the draft. Thank you.
Any questions? So during today's meeting, we are going to have a number of discussions on telemetry, and Ignas is going to be speaking as Ops AD on this. There are ongoing number of implementation streaming telemetry, and would be good if we could agree on how we represent the data. So.
Right, means it is actually not about telemetry, but yeah, how we can create data set which will suffice for the purpose of telemetry. For example, we have timestamp information which we have to add when the particular counter was actually retrieved from the hardware. So that is one aspect. The other aspect could be because in telemetry people actually draw the various graphs and all that. So it will actually be very, very helpful in that case. Similarly, if somebody wants threshold on QS statistics, for example, whenever QS start to drop, that is where I want to see, as a threshold. Now, typically, if somebody wants statistics per interface for the QS, so they will just execute the command and get per interface. But when it is telemetry data, which is pushing the stats on a regular basis, customers don't want to look into all the statistics in one shot. So they want to see the statistics which is critical to them. And that is the reason this thresholding of the counters is very, very important.
So the timing is now because implementations are going. There's a number of what we call native models supposed to do this, and they're somewhat different than what we do here. So again, it would be really great to converge on how we represent data and progress on this work that could address common implementations.
Exactly.
And thank you.
Thank you.
Young?
Hello, my name is Young Lee. Actually, this is the first time I present in routing area working group. This is applicability of ACTN to enhanced VPN. We've been working with Daniel and Jeff and Chin and Daniele on this idea for a while, but we didn't know where to present, and also ACTN was in progress, so maybe right now is a good time to present in a little bit wider audience. ACTN is actually progressed in T's working group and also CCAMP and PCE, but VPN plus enhanced VPN is a little bit larger topic than traffic engineering. So we believe that this working group would be a good basis to start with.
It's not working.
It doesn't work? Manually?
I'll do it for you. Just tell me.
Okay. Yeah, basically, enhanced VPN has the following key requirements. It wants to have isolation between VPNs, which may not happen today is a VPN service, and it has hard and soft isolation. I'll get to what that means later. And also, VPN traditionally doesn't guarantee performance, but now they want to have low latency and low packet drop and ultra low latency with deterministic characteristics, and those things are now coming from 5G transport 3GPP requirement. So they want to provide those service requirement under the VPN Plus package. And also another challenging thing is that enhanced VPN, some instances require a customized control plane to be able to create, delete, modify as they want to dynamically, and they want to have control over VPN. So this is quite challenging requirement, and also seamless integration with both physical and virtual resources. So this is also another complexity. So these are kind of main requirements from VPN Plus, and I'm going to show how ACTN and extended ACTN work progressed in T's working group, and also service model that progressed in operations area can provide this requirement. So next, please. Yeah, this is IETF Young models based on RFC 8309. And I kind of projected ACTN architecture to fit into this reference model. At the top layer is called customer or customer network controller, interfacing networks, maybe beginning with service orchestrator. In ACTN term, we call CMI, customer to MDSC interface, and which corresponds to customer service model in this RFC. And then orchestrator can be hierarchical or it can be flat. As you see in the two middle blocks can be one MDSC, multi-domain service coordinator, or you can separate it out depending on your implementation. And then that MDSC interfacing PNC provisioning network controller, which is basically domain controllers of various types. It can be geographically access, metro, and long haul, and also in terms of technology, transport technology, IP, packet, and optical combination. So basically, there are several models developed in layer 1, layer 2, layer 3 service model in ops area and also CCAMP, and also a virtual network model, which is a T's working group model I'm going to present shortly. And another model we call T and service mapping model, which is very important model that enable services to traffic engineering, because there's a gap between services definition and the traffic engineering. So we develop independent T and service mapping model that maps different services to T primitives, so that interaction can take place, so that services people can understand what's going on their virtual network into the traffic engineering networks and vice versa. An MPI model, which is a very important model. We have base model developed in T's working group, T topology and T tunnel, and then also augmentation of different technologies, starting from layer 0, 1, 2, 3. And then SPI can be applicable with that model. Next, please. Yeah, so this is kind of a recap of what is taking place in IETF, ACTN, T's working group, and ACTN work, and in other areas. As you see, on the left-hand side, we have topology model from layer 0 to layer 3, starting with I2RS, generic model, and then T topology model is worked on in T's working group for layer 2 and 1 and 0. And then we have a specific layer topology augmentation, layer 3, layer 2, OTN, and WSN and flex grid. And tunnel model likewise, we have basic T tunnel model in T's working group, and then augmentation taking place for OTN and WSN and flex grid. But there's another branch called service model. In the ops area, we have layer 3, layer 2 model already I think layer 3 is RFC, and layer 2 is close to RFC, I believe. And layer 1 CSM started in CCamp. ACTN VN and the VNS model actually bind those things together. And then along with T service mapping model to hook those service model to the T systems. And then in OAM, we have another model called PM, performance monitoring telemetry, which is not a generic telemetry model, but virtual network specific telemetry model so that customer can subscribe to what they want to monitor and then be able to utilize that on their behalf. So it's a per virtual network, so which has a little bit different connotation. I'll present that in a little bit. Next, please. Yeah, so this is just a ACTN reference architecture, which I describe it. So we can skip to the next. So ACTN architecture principle, important thing is the virtual network. We allow customer to create virtual networks as they want to see their endpoints. It can be just endpoint connectivity across multiple domains and multiple layers, but they don't want to see, they don't want to bog down details of network layer technology, but they want to create services connecting, for instance, 3 data center locations with certain SLA. But on the other hand, they want to control a little bit more than just endpoint connectivity. They want to own virtual networks, which we call type 2, to be able to put their control plane on that virtual networks, which is one of the important requirements of VPN, enhanced VPN. So this virtual network was conceptualized in the architecture principle, and then we developed Yang model for that. Next, please. So this is IETF ACTN VN Yang model, which is adopted in TIS working group. Basically, this list, one needs to be provided for customer to be able to create their own virtual networks. As you see here, we have access point, endpoint requirements. And how does endpoint relate to T system? T we call LTP, which is, what does LTP stand for actually? Link termination point, that's good, thank you. Yeah, so we kind of connected how a customer end is connected into a T language. And then we define a VN instance, and each VN has a VN member. And VN member is basically end-to-end tunnel connectivity, but you can have actually more than just connectivity model. If you want to have more details, provisioning of each ERO over those virtual networks, you can do that. So basically, we create VN ID and link to T abstract node in the oval. And then we use a T topology connectivity matrix construct to be able to provision your virtual networks for type 2 over a T network so that the customer can control over that topology. So next, please. Oops. Yeah, I think we can skip this because it kind of overlap from the first slide. Yeah, T service mapping model, which we are presenting in the TIS working group tomorrow, I believe. And as I mentioned before, it's very important to bind layer N service model with a 1, 2, 3 to T system. And the service model will provide what service intents are basically, and some policy, but not all policy is specified in a layer specific service model. So we added a few requirements like how my virtual network need to be created in the T system. For instance, virtual network T selection policy or requirement per se. And some virtual network instance, they don't want to share with anybody else. I want to have dedicated, isolated instance of my resources. so that if other people fail, I don't want to get affected by those things. So we have a hard isolation with deterministic characteristic, means I want my latency budget, but also I don't want a variation of the latency. So in order to accommodate that service model, we have to work with packet optical networks together. And optical network could be transport TSN networks for DNet. If we have a TSN network underlay, I think that can be used in order to reduce packet delay, for instance. So we have to work with the packet level and then optical level and any other transport level very closely in order to create the right traffic engineering tunnel for meeting a certain the VPN instance requirement. So basically, we provide this selection criteria in the Yang model. And also availability is a new item that we added because it's not specified in the layer 2 or layer 3 SM model. So we added in TIS mapping model so that we can close tie with what service wants to the networks. Next, please. Yeah, so this is details of TIS service mapping model. I think because of time limit, I wouldn't go over detail, but it's listed in the draft, and also this will be presented tomorrow in TIS working group. So basically, we are binding VPN to TE system closely. Next, please. Yeah, another one that I mentioned earlier on was performance monitoring, telemetry, and network autonomics. This telemetry is not same telemetry that we are used to, but rather a customer subscribe to what they want to see and collect for their virtual network, because virtual network has certain characteristic, and I want to look at my latency and then utilization and combination of the two, for instance. Question?
AC Lindum. Young, so this is being presented here. All these Yang models are staying in the TIS and CCAMP working, you know, the ACTN in the TIS, in the CCAMP working group, and TIS stuff in the TIS working group. This is in the context of the telephony discussion that follows? Is that why it's here?
So,
or was it just an open slot?
No, not necessarily.
Okay.
So if you look at anything from service model to device model scattered across IETF, so my intention here is to provide vertical view from service request up to configuration, and again, creating protocol models without understanding service requirements is pretty much worthless unless you can build full vertical from service delivery up to running network. Our work here is, you know, unnecessary. So the intention here is to show workflow of from service requests coming from business logic or SSBSS layer up to the network, and eventually what we do here should be plugged in vertically.
Yeah. The reason I asked is because if you don't have the context, you know, I haven't been following CCAMP or TIS. It's really it's at a real superficial level that I'm seeing this.
I agree.
Okay.
Yeah, actually, the actual Yang model is progressed in TIS working group, but this is a VPN applicability, VPN plus applicability, which we believe it fits in here as an information model, not as a standard draft, but introducing how AC10 can be applied for VPN plus. And I believe Louis is coming, so he might say this is actually TIS working group item, but which I didn't know what conversation.
Undoubtedly, he'll say that.
Yeah, between Jeff and Lou, I didn't know where to start, but I present here first. Yep.
I'm okay with it being sort of the visibility of the work being socialized here. So, you know, whether it's here or somewhere else, I think it's helpful for more people to understand it. At the last meeting, we talked about Stewart's document, which was aiming to be a little more looking at heading towards the protocol extensions, even though it doesn't have it yet. We had said that it'd be moved to TIS, and in fact, He did republish it as a Teams document, and it's on the agenda there. You know, it seems like this should sort of go with it, although to AC's surprise. But I'm also okay with having it talked about here because it hits multiple areas. And we're not necessarily going to get everyone in the room in T's. So it is a little bit redundant, but it's not necessarily a bad thing.
So if you look at the workflow of this meeting, next presentation is going to be talking about streaming telemetry, and then Ignace is going to talk about evolution of management, and intentionally so.
Rob Wilson, Cisco. So just a quick question is, are you aware of the work that's being done in MEF regarding the life cycle orchestration model, LSO model? That seems to somewhat overlap in terms of the different service layers and get it down to device layers. So
yes, I'm very familiar with LSO. I'm going to MEF next week.
Oh, fine. Okay.
But I identify gap there. They don't actually have this mapping per se. They have a lot of service model, and they actually use some other traffic model from other SDOs, not necessarily having their own.
That's fine. I just want to check you're aware of it.
Sure.
Thanks.
Relaying a question from Greg Mursky. Yeah, but I'm relaying a question from Greg Mursky, so it's not me. How does the model control performance measurement protocols?
Could you say that again?
How does the model control performance measurement protocols?
Performance measurement protocols. I don't know what that means. Performance measurement protocol.
OM protocols.
Oh, OM. We are independent of that. Okay, this is actually the right slide, which I haven't explained. Basically, customers subscribe to the performance metric they are interested in for their service. For instance, I want to have latency, strict latency, 50 milliseconds from endpoint 1 to endpoint 2. But endpoint 1 to endpoint 3, maybe I have a little bit different requirement. That's called virtual network, okay? So they subscribe it, and then a network basically collect from various level to drive that, the performance matrix that is meaningful to the customer. So customer only see end-to-end measure, and whether if it is met, they are satisfied. If not, they have ways to scale in, scale out, depending on the performance metric. So next one actually shows some examples.
Just a follow-up question from Greg. What produces these metrics?
What produces these metrics? Actually, device link level has to produce link level latency, but customer is interested end-to-end connection level. So you have to stitch it together at the orchestration layer or network control layer, collecting from domain level link statistics, for instance, and then give the information to the customer. Okay?
Thanks.
Yeah, so basically,
we need to.
Yeah, so this model is here, so take a look. And tomorrow, actually, in T's working group, we are going to present another presentation on this detail for 10 to 15 minutes. So please show up. Okay, go ahead. Yeah, so this is the last slide. Basically, the point here is that all those are 4 important requirements for VPN plus or enhanced VPN is basically met with service model and ACTN models, VN and then T service mapping and T telemetry in conjunction with T topology connectivity matrix model. And we also have SF-enabled topology model in T's working group, which will be also presented tomorrow, which is not original ACTN scope, but T's working group has been working on that, how to have topology that is SF aware, virtual network function aware, so that you can use this model to do more than just connectivity. So yeah, this is my last slide.
Thank you.
Yeah, thanks.
So if there are any questions, please to the list, and probably to the TS list, not routing.
Yeah. Okay.
Thank you. Thanks. Robin?
Okay. Hello, everyone. So this is Robin. So my presentation topic is the network telemetry framework. Okay. In fact, this has been presented in the last IETF meeting in both Rtgwg working group and also the OPSAWG working group. So we would like to introduce the latest progress about this work. Okay, so here is the updation of this standard work. So that is after the presentation, we get many these comments and also get the more cooperation from this TI and also the China Mobile and also the NICT and the Nokia and the Telecom. So that based on the comments and the cooperations, we update the draft and this show the progress of the telemetry work. So the first one, that's the clear definition and the characteristic summary of the network telemetry. Because in the last presentation, so that's the many had a concern about the scope of the network telemetry. So we also would not want to boil the ocean. So that in order to clarify the scope, so that we, in the draft, we determine the propose this the clear definition and the characteristics about the network telemetry. Based on this, so that's we have a hope to understand the clear distinction between the conventional OEM solutions and the network telemetry solutions. The second one, that's the new module for the framework. So that's the external data and the event telemetry. So that's we get this comments from this cooperators. So they said that not only the management plane telemetry, control plane telemetry, and the data plane telemetry in order for the telemetry work, so that we need some of the act data and event telemetry beyond the network self. So that's this is a new module for the framework. Okay, any comments?
There was a question from Greg Mursky. When you refer to telemetry, do you mean telemetry information as network state information, or telemetry protocol as protocols to collect and or transport network state information?
Both.
Okay, and another question. Would you agree that the machine readable is what you refer to as telemetry?
Sorry, what?
Would you agree that machine readable
is
what you refer to as telemetry?
Yeah, yes.
Okay, thanks.
Okay. And the third one, that is a new content for the control plane telemetry. So that's we identify the requirements as the challenges of the control plane the telemetry work. Because now that much work is related with the management plane and also the data plane. So that is after we examine the requirements and the challenge of the control plane telemetry. So we propose that's the network monitoring protocol. So that is used for the control plane telemetry. So this has a similar triggered by the similar source from the BMP. Okay, and the last point, that is a new content for the data plane telemetry. So here, that is because we have the many OEM mechanisms or the telemetry mechanisms. So here we have the terminology for the technical classification. This classification including the active and the passive in-band and out-of-band E2E. That means the host will aware of this telemetry or this in-network. And also that is identify that is a flow level, path level, or the node level. So that based on this, is easy to classify the different technologies. Okay. And then also there's new technologies introduced. This is the important work is the IPFPM, so that they use that's the alternative mark for the inbound traffic for the point-to-point and the multi-point to multi-point service. Okay. Okay, so this is we review the work. The first is the challenge of the today's network. So now that's the network becomes more and more complex. In fact, it has to support reach for the applications. This including cloud, 5G, IoT, overlay, underlay, and VPN, network slicing, etc. And now that is in order for the byte network application sensitive and also become less sensitive to the network performance. So this including the parameter such as the bandwidth, latency, jitter, packet drop ratio, and network churn like this one. So that's the network visibility is become more and more important for the purpose of the network OEM, provision, planning, security, and the troubleshooting. So, and also this our old tools for the network visibility, we think is not enough. So the first drawback of the old tools is the lack of the application level visibility. So it's always the network level visibility, and that is also insufficient. And then the second one, we think that's the lack of the automation tools. Okay. Yeah.
Comment from Greg Mursky, who just wants to make sure that you're familiar with the work of the LMAP working group, in particular, informational and Yang models.
I mean, you first, that's what work?
The LMAP working group. Greg wanted to make sure that you're familiar with that work, and in particular the information and the Yang models.
Yes, I think this is definitely be taken into account about this Yang model. Yeah.
Okay. Thanks.
Okay, and this is the next one. So this is also we face the challenging of the fusion network. So now that is the network management and service evolve to become intent-driven and automatic. So this is we have identified the possible characteristics. So the first one is to reduce the man labor, human labor. The second one is improve the agility and the performance. And third one to optimize resource efficiency. Yeah, and also everyone so that know that now that maybe for a typical network is that maybe we have the hundreds of the device of the almost the tens of the hundreds of the device.
Robin,
but
you run out of time before you've covered half your slide.
Okay, I'll try. Okay. So I will this in order for this one. So we have this in order for but now that is as an NFV of the virtual and the cloud-based device. So that is we have the huge amounts of the devices in the network. So we think this the network visibility is become a very, very challenging work. So here we think that we hope to identify this the network visibility based on the network telemetry to set up this closed loop and to improve the intelligence. Okay, so this is the current solution. We will skip it, but this may be familiar with this one, SMP, syslog, SMP. Okay, so here this is we identify this the distinction between the conventional network OEM and the network telemetry. So for the yellow one, we think that is the characteristics of the conventional network OEM, and for the green one, so this is the characteristics of the network telemetry. So here we can say that is the traditional is distributed based, and now we must take into account the SDN, that means central based. And also, old one is pull-based, but now is pull-based. And also now that's is streaming data and also the big data. And that's now that is a human consumer, but now that is a machine consumer that for the automated. And then the traditional we use the CLI, but that is the more programming. And also that is the old one is reactive, but now that emphasize on the proactive. And that is troubleshooting, but now that also emphasize the prediction. And also that is the independent tools, but now that we want the unified and the correlated tools. Okay, based on this work, we can see here, that's the network operation applications. We think this is the control plane telemetry, management telemetry, data telemetry. Now that we also identify external data and event telemetry. So, and also here, that is the whole picture of this, the different plane, and also this the different components from the 5 aspects. Sorry, I must finish my presentation. Okay, and this is also that is we based on this the picture. Also, we identify the challenge of the network telemetry for the top-down this design for the new technologies and solutions or improvement of the existing technologies. So this here including the dynamics and the multiple resource and the performance impact on the network telemetry solutions. So this we also to get our this the design and the improvement. Okay, so here we would like to this the conclusion. So the first, so that we want to promote the significance of telemetry work in IETF. We think this IETF is the right home for the telemetry because this is the protocol related with the device and the controller. Is not only this is high level work. Second one, we also want to formalize the telemetry related terms and technology classification in IETF. So this is also to consolidate existing work and also to get a future network, future work. Okay, and here that is we, I just mentioned briefly here about network monitoring protocol work. We propose this draft. So this draft is to for the control plane monitoring, and we also use for the control protocol telemetry. So this after this draft is being proposed, we get a lot of comments, and so here that we would not to discuss more in this session, but welcome to GROW working group and the OPSA working group for more discussion. Okay, so this is our the next steps. So this is solicit more comments and feedback, and this refined draft. Okay.
And it's not to the previous slide. It's to the draft you presented. You sneaked the last slide, I know. Okay.
Benoit Claes. So I was listening to what you said at the same time reading the draft. So I've got no disagreement with what you said, but in your draft you wrote that network telemetry demands new techniques and protocols. What do we need that we don't have already for the IETF?
Sorry, you mean existing IETF, the protocols?
What new protocols, what new techniques do we need that we don't have already?
Okay, so
in the industry or here in the IETF?
Okay, so the first one, so this is in fact this is the some to consolidate the existing work in the IETF. This including the netconf improvement and the gRPC, and also that is the IOM like this one. But also that is some this is the BMP and this is the NMP. So this is the protocol.
Right, but okay, for BMP, what do you need to improve to push it via telemetry? For IOM, what do you need to improve to push it via telemetry? gRPCs and encoding, okay, fine. So it seems that you've got all the pieces already, and you're describing something which is like a framework or product or something. I'm just missing what needs to be done here.
Yeah, I think that's you think this is maybe this is you think this is relatively you think is a new protocol or this is the existing protocol. From our point of view, maybe the gRPC comparing with the traditional, there's the SMP, we also think is a new protocol. So we think that's you can see that we have some of the existing work, we try to consolidate that one. But we think is maybe lack some of this, we get some of this new requirement so that we enhance the protocols. So that's we also think some of this new protocol extension. We will not would like to that is create a new protocol or like this one. That's not the purpose.
There's a comment from Greg Mursky. I believe that it is critical to differentiate telemetry information and telemetry protocols and scope work properly.
Yeah, we would like to do this one. So this is also, you can see we do a lot of work. So that's we define this the terminology and clarify the distinction. So that's just want to identify this the scope carefully. And also there's the scope of the different solutions. So that is also the purpose of this NTF work. Okay.
Thank you, Robin.
Okay, thank you.
You want to ask a question? Or?
Yes, I had a question actually. So Ignas Bagdonas. Did you try to socialize this topic with the potential users of the solutions that you are proposing, that is the actual operators? And are the problems that you are stating as problems, in fact, real problems, realistic problems that are happening, that are still current, and whether the solutions that you are proposing, in fact, fit into the operational model of the existing operators at all?
Sorry, I cannot catch all your points. Maybe this we have the offline discussion.
Yes, certainly. So, short form, have you socialized your work with the operators community? Not with an IETF?
Sorry, socialize with operator?
Operator community. So other places than IETF, other places where the people who run the networks and talk about these things gather and discuss the actual problems.
Yeah.
Talking about NanoGripe and Apricot and places like that.
Yeah, definitely we think the operator and the carriers and OTTs are very important for us. That this not only this the network, but also we can borrow the source of the existing IT technologies. They use the maintenance technology for the computer resource and the storage resource. In fact, we had a lot of discussion with the OTTs. Also, we present this work in the MPRS Congress called in the Paris like this one. So that also we can see this is many, this is the customers, the operators, co-authors. We just also want to increase this the reasonableness of this work.
All right, thank you.
Okay, thanks.
So, Robin Coulters, I mean, it sounds like we should jump higher, better. For the next steps, I would really like to see proper comparison between existing tools, what could be done, and what you think is missing before going and tell everybody we need something new, let's assess what's there, how it could work, and indeed talk to the consumers of the technology, asking them what's missing. Robin, talking to you. Never mind.
Right, so a quick overview from the ops and management area on how Yang is doing overall and what can be done about that. Next slide, please. Actually, I think I have that. Thank you. Well, it appears that Yang is doing not so that well. And this is rather alarming. IETF as an organization and we as a community have spent 15 years working on the new paradigm of manageability, but the big question is whether that solves actual problems, whether that is actually getting deployed, whether that is getting deployed in a way that we as IETF understand, and whether we understand, whether we are trying to solve the problem which is in fact the actual problem, the way how the operations community sees that. One of the alarm, I would tend to use the word alarming, but it's probably not the right one. The concerning development in the industry is that there is a large uptake of configuration, parameterized configuration-based fragment manageability mechanisms in development and in active deployment, which is in fact a reinvention of Yang in a slightly different syntax, in a slightly different form, but which solves the problem in a way that the operators community understands and solves that in a timeline which is far faster and far more acceptable to them. Yes, if you take a look at the overall look of the Yang-based manageability vision, it's really beautiful. If I want to use that today for practical purposes, can I do that? Not really if we look at the practical aspects of that. We do have fragments, and IETF as an organization overall is good at developing fragments, protocol fragments, Yang fragments, and the like. IETF is historically not good at dealing with systems. If we look from an operational point of the world, what matters is a system, how the components and the fragments bind together, how do they work. And as an operator, I do not care whether the protocol is this or that, or whether I use this mechanism to get something or that mechanism. What is important for me is that I treat that as an end-to-end system, and I deal with the actual tasks that are needed for from a service perspective. The element does not matter, the protocol does not matter that much. So practical completeness of the models. You can do quite a lot today with based on the models that are being developed for different protocols, for different components. But very likely you can do 80% of what is needed practically. Yet the model covers much more functionality than that, but it's 80%, it's not a full functionality that is needed for majority of practical deployments. The other important aspect, practical aspect, is the state of the tooling. Developing a model might seem to be the end goal. No, it is not. The fact that the model exists, but I cannot use in a practical way, it's equivalent to the fact that the model cannot be used. There are two sides to this. One is the education. Operations community does not necessarily have the level of understanding of what model-based manageability is overall. You here all spent decades talking about Yang and developing the things. You know the intricacies of the language, the modeling process, and the like. It's not necessary that the actual operations community has that insight. It's a question of education. The other aspect is tooling and workflow processes and how that integrates into the existing tooling and the workflow processes of the operators. It's unrealistic to expect that greenfield deployments are widespread and do exist. You have to deal with things which are existing already. You need to integrate into that. If you have a beautiful solution which cannot work with what you have already, it's just a reality that investments done into building working but obsolete system are not going to be withdrawn just for the reason that IETF made yet another shiny Yang model. That is not going to happen. Another important aspect is the widely known 20/80 split. We might have 20 large entities, tier 1 operators of any particular, unspecific type. which probably already are using that, and if they wanted, they already have invented some other model-based or non-model-based manageability mechanism. They are large enough and resourceful enough to build what they need themselves, and in fact, they don't need IETF for that. And the remaining 80,000, not just 80, are the ones which rely on what vendors deliver as a common set of the requirements which are coming from all 80,000 of them. And that is the group which requires IETF and IETF to come to the practical solutions which are usable by majority of them, not absolutely by them, by all of them, and at the same time not selectively by only a small fragment. So if we look at the overall split of what is needed from a manageability functionality, it's probably more practical that IETF focuses on the requirements of the 80 side than frequently more heard and more visible requirements of the 20 side. So I'm not saying anything negative about any of those 20 or so tier ones, but the solutions which are applicable in their environment most probably are not applicable in the environment of the majority of average network operators. And the open question is where IETF stands in that, which direction it follows and to which voice it listens, the one that is louder or the one that is not necessarily represented due to the fact that operators are not present here for various reasons. What to do about that and then how to progress forward. So this is an open experimentation. We do not seem to have a channel with the operations community about how things are being used. What are the actual problems? And we also do not have a channel to sense the feedback of those mechanisms which IETF develops, whether that fits into the environment which operators are using. So it's a bi-directional communication channel to get the requirements, what are the problems and how to solve that. The alarming point for me is that we are in a situation where vendors are telling operators how to build their networks. That just does not seem to be right. Vendors certainly have insight on how to build platforms, but the platform is not a deciding component. And it's just not right overall from an operational point of view to try to build a network based on a platform. The platform is just a brick which provides some function, but the overall end-to-end design is not something that is governed by the particular functionality of a platform. Yes, it limits the aspects, but that should not be this way around. So IETF is open for doing an experiment. Maybe a working group, maybe some other format of such communication channel. And if we look at the previous results of what Rtgwg design team did, they resulted in a rather good overall framework for the routing manageability. But routing is a fragment. If I want to run a platform, if I want to run a service, there needs to be much more things than just routing. Routing design team took a problem and then tried to work on that, trying to align with the community. The good thing that many of the, well, many, but at least there were operators who were the target users for that. If we are talking about a broader scope of usability, certainly we don't have enough of a participation. Therefore, the idea is to have an experimental working group or some other form, which is across organization. So we have several large operator events, communities, NanoGripe as a minimum. They do have their own working groups. Maybe it would be good to try and experiment with having a joint working group across 2 or 3 such organizations. From IETF side, this working group would produce informational documents at most, and maybe not even RFCs, but temporary working documents which guide the development of other, particularly protocol level models, both on element level and on the service level. The most important part is to understand what are the problems that we as an IETF need to try to address for the operational side in order to stay relevant. And that, to me personally, that appears a problem. IETF is historically good at developing solutions, spending enormous amount of time on that, and eventually those solutions just don't get deployed. For various reasons, sometimes good, sometimes bad. I'm not saying that Yang overall is moving into that direction, but there is a risk. One of the reasons for that, that the checkpoint of the model-based manageability was around 15 years ago, the workshop that I mentioned, IAB workshop, on what are the problems and then what needs to be done. Since that time, quite many things have changed, both in the operational side of the house and also in the protocol machinery and mechanics and so on. So, however, much of the work on the model development seems to be still based on the assumptions of the result of that history. Open discussion. Any comments, any feedback about that? Just about absolutely anything.
Dejan Bogdanovic. I was part of the Rtgwg design team, working, like design team, and my issue is mainly that we discuss about a lot of models without actual implementation. Unless people start writing code for what they're trying to model, nothing will change, because until then, you will have experience how things are going. The other part is what you said about the other 80,000. The other 80,000 are still very happy with the CLI. There's a still hard requirement. It has to be a CLI. It has to be what we are used to. So once you start talking to the operators, this is where many of them are still there. Yes, there are early adopters they're putting into it, but many of them are saying, well, we only know how to debug with the CLI. And one of the issues is also that we have to think about more is how we will create debugging tools. It's not just the modeling. Exactly. It's how, once you put it out there, how will you solve, how we will figure out when there is a problem introduced into the network? Which way will this be? We are a lot of focused on the configuration part, but we have to be also much more focused on the operational. And one of the things that the existing vendors have is the translation between the config models and the operational models. These two, to figure out what this configurational model means, to this operational model, and the translation between them, that is a major problem. And we are still building models in the IETF. Here's my config model, here's my operational model, and I have to figure out how will I translate from one to the other.
Yes, exactly. That's a valid problem. That's part of something that somehow needs to be solved. Now,
and on the, so on the last part on the tooling, I think there are good tools out there. They're proprietary. There isn't much open source. There's almost no open source tooling out there available that is worth putting together. So unless there is, again, a group willing to put something to get, put energy into it, and we will have to rely on commercial tools that are either built in-house proprietary or you can get it from third-party vendors.
My comment was not specifically splitting open source versus commercial. It was just a general comment that, yes, there are tools. They are not to the level of where the majority of the other tool sets, not Yang-based tool set is.
I disagree with you to a certain extent, but that's fine.
AC Lindum, Cisco Systems. I'd like Dan to review our models that we're putting forward right now in ISIS and OSPF and see if they're in the sad state of having the ops state and the config split, because I think we've done a good job of putting them together. But anyway, aside from what you're saying, do you have some strong people from the operations, from the providers to lead this right now that have not only strong, but that have the amount of time to devote to it? That's the key thing. That's the key thing here.
Short answer is probably yes. And that is the reason why this experiment is being tried.
That would be great then. I think it's a good idea.
This is not something that happened overnight today. This has been socialized for quite long with that community. And yes, I have been trying to pull in some people and then twist their arms in trying to do that. If this goes as, say, as a working group or an equivalent of working group, certainly the chairs would not be from IETF community.
Benoit Claire, so Ignace, many points I want to make. So first of all, I think it's a great idea to reach out to operators. I agree with the code aspect that Diane was mentioning, right? Just working from Yang models without actually having the tools and the code, it's like the first step, not good enough. We keep telling that people need Yang. Actually, Yang is just a means to an end. What we have to do is show to the operators how they will be able to reduce the OPEX. And then those 80,000 or many people there would see what they could save. But if we've got the Yang and the tooling and everything, plus the education, that's a big thing that we need to do, right? What else? We reach a state where we've got Yang modules, but they're not coordinated. This is the biggest issue we have for routing. It's good, as you mentioned, for the entire industry. It's not there yet. So basically, it's a good experiment. Go for it.
So just to summarize, Yang is a tool. It's not the goal. It's just a tool.
So, and this discussion is not coming out of nowhere. We've spent last 6 months with Ignace Humor people going to Nanox, Enox, RIPES, talking about exactly that. And feedback, in theory, we would love to use Yang models. We understand the value. We don't know how, we don't have the tooling, and it makes to some degree our work irrelevant because it cannot be consumed. So unless we solve this issue, we should be asking ourselves, what is it we are doing here?
Robin from Huawei. In fact, regarding this, I think this is a good topic for the discussion. This one I have much want to say, but I tried to catch some of the key points. So the first I wanted to from this some aspects. The first one, I think we in the past years we do the huge work about the Yang model standards. I think that's almost exhausted some people's efforts. I think that should be appreciated. But the second one, that is, in fact, I think that based on my observation for the Yang model that's used in the industry, I think to some extent, I pessimistic about it. It seems that now that we is enter into a negative cycle about this work, because that's the Yang model is not enough for the application or cannot catch up the new application. So that, but user they want this one, so that we have to define the private Yang models. But after the standard Yang models are available, so that they would not like to change the existing private Yang models. So that is to split is again. And also this is based on the open source for the practical completeness, but that is only can be applied for limited scenarios, cannot satisfy all the requirements. So that is also cannot solve the issues. So I think I little pessimistic about this one. So I also, the third one, we also thought about the possible solutions. So I think first is yes, we should try to set up the channel with the operation community In fact, in my presentation, I also mentioned and also a lot of people observed about this, the OTT, also this IT companies for this work. In fact, they also face a lot of challenges about this operation, but they have the reachable tools for this one. This is not only the standards, but this operations, but also this is the operation community, and also a lot of this summit, and also this the open source. So that is active, and there is a lot of information and the tools can be shared. But until now, but for us, and is for the traditional conventional vendors, so this can be we can borrow some experience from this work. This is the first point. So the second point, so that is I also that in fact in my NMP presentation that will be done in the OPSA WG, and also that's in the GRU WG. I want to also mention this is the possible one because
please.
Okay, I will try. So that means that the young model is the tools, but in fact we can change now that we change some of the configuration, existing configuration to some of the control protocols. For example, the PCE, for the stable PCE, that means use the PCE control protocol for the provisioning for the tunnel. So I think this is the advantage of the IETF. So also we can think that is also think about that we change to some this work use this method because this is more incrementally. Yeah, so that's yeah. So I just say this one.
So yes, quite many points. I will respond in summary with one answer. Not certain how much you will like that. Just the fact that something can be done does not necessarily mean that it should be done. And we have plenty of a selection of various protocols and other things. And we better use what is already there for the simple reason. It's much higher probability that operations community is aware of that and know how to deal with that than to try to invent something completely new, which does mostly the same what the solutions which are existing.
So, and back to AC, the most beautiful OSPF model wouldn't make for working service. So unless there's whole vertical that enables the end consumer to deploy a service, it doesn't really matter unless all the pieces are put together.
Dan Bogdanovic, actually I have a concrete proposal, putting 2 and 2 together and see if you're already proposing something like a design team, let's try to start it, and I would even be to volunteer. So within a certain open source project, we've been starting to add support for young models to various routing daemons. And that's a pretty active project. We are starting to develop code, adding things to it, coming up with different abstraction proposals. Some of them is, okay, let's do just like a standard, more or less what is a CLI, and the other one is, let's try to see some of the abstractions. Enough of us vendors here have experience, not first-hand but second-hand, through communicating with the operators what they are looking for. And we might run a project that, let's walk the walk, not just talk the talk, where we can come up with some of the proposals, try to implement them, and see where it will take us. And we will have a first-hand experience, because what we will be first implementing, and after that we will be discussing about the actual model.
Great idea.
Rtgwg Volksdeutsch Telekom. Dean, are you heretically going back to the running code thing?
Yes, I am.
And well, okay, actually the running code thing that not only per se has been lost somewhat on the way, but also the running code that actually can be used.
That's fine. So the whole point there, what I'm saying is, there is a group, we are starting to meet at the IETF quite regularly. And instead of just talking, come up, on there, we can have the project, we can do it in parallel and see what works, what doesn't. That's the reason why I withdrew myself from several, drafts, because they started to do and work on things that weren't implemented. And I weren't, happy with that.
So your office is noted. The plans, the time frame for that is probably will be around 103. There are many things that still need to be clarified. There still are other events on the operation side which need to be discussed and presented of this idea, but that will likely to happen.
So I will ask you, why do you need to wait until 103? Why cannot it be done within the interims? Because we are moving forward.
It's not waiting strictly for 103. What I was saying that for the 103 time frame, something might happen.
Okay. So let's decouple these two events. I think what Dean described, we should start it yesterday. Right?
It's just you want to formalize it, and we're happy to formalize it with what you're saying.
So our idea is here in front row. Martin? So it looks like there's a proposal to form semi-formal working group, not working group, design team, and start working, looking into real implementation, which is what we should be doing, right? That's what IETF is for.
I'd like to go judge interest beyond the few people that have commented on the mic and express their interest, and if there is sufficient interest and willingness to move forward, that could be an option indeed.
Thank you.
So, Ignas, you were there today. We had about 20 people there in the room. I mean, we should.
I wasn't.
No, I know. Yes. So I said, it's a matter. There is already something that we are doing on the sides of the IETF, and you're just using the IETF to talk more about that.
So we'll start this war pretty much immediately. Robin.
Okay, okay, I want to give sequence. Okay, so that's regarding this young work. I wanted to add the possible suggestion for this one. So that's in fact for the past years. In fact, we have do a lot of work to some extent on the pieces of the young model. We have the IDP and the BDP, also the MPRs. So now I think maybe this is the right time we sent this the design team that is based on some of these the useful cases to examine the existing pieces of the young model. Is can satisfy the requirement, or this is the requirements of this the solution based on this the use cases. So that's I think maybe easier for us to communicate with the operation team, because they always care about this the use cases and the solution. But you always talk with them about some of this the IDP young model, this young model. Maybe they cannot set a picture. So that is also this is my suggestion, because now I always encounter this situation. Even for the operators, they just give this is the young this is the RFC or the draft list, so a lot of young models to us. But in fact, I talk to them what you want. They can also not explain what they want. They just say this is the working group draft this RFC, please. I think this is not our purpose.
So it seems that there is a simpler way to get the sense of the operators community than trying to design a design team within IETF which will work on our problems. It's much simpler to go out to the operators and ask what are their problems, and then based on those answers try to develop the solutions.
Yeah, I agree.
So we'll start talking immediately after IETF how to form the group. We've got a number of volunteers, and I know all of us have our primary job. If some of you could spend 5% of your time contributing, I see Donald smiling, would be great, and it would be so useful for the community and people who pay our bills at the end, right? Thanks, Ignas.
Right, thank you everyone.
We've got second meeting on Thursday. Looking forward to seeing you again. Thank you.